In last video, we looked at data collection for our image processing project. In this video, we are going to talk about data cleaning. In any data science project, majority of the time is gone in data cleaning process, and you will see that in this project also we'll be spending significant amount of time in cleaning our images, because when we download our images from internet, the images might have a lot of issues. Now, when you want to detect a person from that image, just think about it. Like when I show a photo of a person, how would you go about detecting that this person is X or Y? Majority of the time, you will be using the face of a person. Now, using the height, hands and legs, you can tell about a person to some extent, but your final decision of who that person is mostly based on the face. And we are going to use the same concept. All the images that we downloaded from Google, we'll first try to detect the face of the person. Sometimes face might be obstructed. So we want to detect if the face is clearly visible or not. Now, how do you detect that? So you will try to detect two eyes as well. So if in a photo, you can find a face with two eyes clearly, then you will keep that image. Otherwise, you will discard it. For face detection and detecting the eyes, we will be using OpenCV, which is a famous image processing library in Python. And for the specific detection, we will be using a technique called Cascade. That's a famous technique on how you can detect the face and the two eyes. And we'll see how exactly you can do it. It's pretty straightforward. At the end of this tutorial, you will have a clean data set that you can do further feature engineering on. Here are some sample images from our data set. You see a lot of variety here. For example, here Serena Williams' face is not clearly visible. In these two pictures, along with Virat Kohli, there are two other people. Here is Anushka, his wife, and MS Dhoni. In this picture, Messi's face is visible, but it is only a side face, so his two eyes are not visible. Now, how do you handle these different images? Let's look at a very simple example. So this is the image of Maria Sharapova. Here, the face and two eyes are clearly visible. So we'll detect this using OpenCV. And once you detect face and two eyes clearly, you keep that image. In this photo, there are two faces. So first we'll detect those two faces, and using OpenCV, you cannot say that this is Virat Kohli versus this is Dhoni. OpenCV can only tell you that there are two people, and here are the regions where they have their faces and two eyes visible. So once you get these two cropped faces, we'll have to run a process of manual verification. 80 to 90% of our data cleaning is happening through our Python code in automated way, but there is 10% where you have to spend manual effort in cleaning your data. So we'll delete image of MS Dhoni in the manual verification step. In this case, Serena Williams' face is not visible properly, hence we will not use this image in our classification, because if we do, then our classifier might make mistakes. So we want to make sure our classifier's accuracy stays high. In this image, although we know Messi from the side face, for computer it might be hard if two eyes are not visible, and hence we will also discard this image. So just to go over the overall data cleaning process, you had raw images, you created cropped faces, you detected basically the faces out of all these images. You also discarded some images where faces were obstructed, such as Messi's and Serena Williams' pictures are not visible here. Then you run a manual data cleaning process where you delete unwanted images. In our case, we are doing a sports celebrity classification only for 5 players, which is Kohli, Roger Federer, Serena Williams, Lionel Messi, and Maria Sharapova. And here there is an image of Anushka Sharma and Dhoni, who are not our classification classes. Hence, we are just deleting those images. In the next video, we'll be looking at wavelet transform and how you can do feature engineering to extract the features from the cropped image in an effective way. We'll then use this wavelet transform images as well as the raw images. We will do vertical stacking of raw and wavelet transform image and train our model and then hypertune it. Once that is done, we will save our model to a file. And we have already looked into this architecture where we'll write Python's Flask server around it, which will be serving to our website. Let's jump into coding now. In C code dry, I have created sportsperson classifier folder where I'm going to host all my code for this project. I have already created 3 different folders. In the model folder, we'll do model building and the training. The server will host Python Flask server code and UI will host UI, of course, it's obvious from the name. If you go to model, I have placed my dataset, the Google images that I downloaded into this dataset folder. So you can see that there are 5 people here. If you look at Maria Sharapova, all her images will be in this folder, and same applies to other players. Okay, so you have already done that. The other folder I have is OpenCV. I will talk about that folder a little later, and I'm gonna provide this folder on my GitHub, so you check it in a video description below and you will be able to download this folder. I also have requirement.txt, which contains all the modules that you need to install. And the way you install it is you go to your command prompt and see here right now I am in this folder, so I can just go to my model folder and just say pip install -r requirement.txt, and this is how you install all your modules. Now I have already installed these modules, so it's gonna say these modules are already installed. If you get this kind of error where it says access is denied, what you can do is you can start git bash as an administrator. So if you run it as an administrator, you will be able to install things okay. I assume that you already have Anaconda installed. So you install Anaconda, and on top of that, you have to install these 3 modules. I'm gonna provide a requirement.txt file, which is this, in my GitHub. So again, you have to just download it and just run pip install -r on requirement.txt. I also have this test images folder, guys, where I have a couple of test images to try a few things. And with that, now we can start our Python coding. So I opened Jupyter Notebook. I created a new notebook by going here. I call it sportsperson classifier model and imported a couple of important modules here. This is a CV2 module, which is OpenCV basically, and it will be helping us a lot throughout this project. So the very first basic thing you can do in CV2 is read an image. So here from the test images folder that I have, I am reading an image of Maria Sharapova. Okay, so this is a beautiful looking image. I'm just downloading it, and when you read this image in CV2, you will realize that the shape has 3 dimensions. So this is X and Y, okay, X and Y coordinates, and the 3rd dimension is the RGB channels. You know that any color can be represented using RGB values, and therefore you have this 3rd dimension for your RGB values. Now if you want to quickly show that image, you can use PLT, which is matplotlib basically, and PLT has this method called im.show, and that will show you this image. Now when you look at this image, it's a colorful image basically, which has RGB values, and if you want to change it to a gray image, you can do something like this, where you can see that it is removing that 3rd dimension that you have. All right, and the gray values, I mean, ultimately they all are numbers. It's n-dimensional array with numbers from 0 to 255. And when you plot a gray image using, again, a matplotlib has this imshow function. You can use cmap gray. The gray image looks something like this. Now we are going to detect the face from this image and also the eyes. Now if you look at OpenCV documentation, they have this nice article on how you can detect face and eyes using Haar Cascade. We are not going to go too much into detail on what is Haar Cascade, how it works, because it requires a long discussion. But just to give you a brief idea, you have this line and edge features, and it will use a moving window of these edge features to detect where is your nose and where is your eyes. For example, in this image, when you have eyes, the area of eye tend to be more darker than the area below. Similarly, when you have nose, the area of eyes tend to be darker and the tip of the nose will be little brighter. So you can use all this mask to detect these areas. Okay, and OpenCV documentation contains this ready-made API which you can use to detect the face and an image. So if you don't want to bother too much about the Haar Cascade and inner workings of it, just assume that there is this cool technique called Haar Cascade which helps you detect face and images, and your result will look something like this. So I'm going to try the same code here on our image of Maria Sharapova. Okay, now going back to our folder structure, let's see here. We had this OpenCV folder which I downloaded it from OpenCV GitHub, and it has all these Haar Cascades. So what are these Haar Cascades? They allow you to detect different features on the face. They allow you to detect face, eye, left eye, right eye. So these are the different XMLs or pre-trained classifiers that you can use for detecting various features. And I'm going to first try face. Okay, so, and I'm just copying pasting the code from my other notebook so that it saves me time on typing, because there is like a lot of code that we'll be writing. So I loaded that XML file which is called front face default, and also I loaded eye cascade. I'm not using eye cascade for now. So when I load face cascade and when I say detect multiscale from this gray image, what is this gray? Gray is nothing, guys, but this gray image of Maria Sharapova. On that, you are saying now detect me faces, and what it return is an array of faces. So if you had two faces, it would return two faces. Right now it return only one face, and this is an array of 4 values. So what are these 4 values? So it is your X, Y, width and height. See, this image has this scale, so 352. So 352, see, you see 300 here, so 352 will be somewhere in between this, and 38 will be somewhere here. So see, at this point the face starts, and the width and height is 233. So you go 233 here, 233 here, and this will be your face. So let's draw that face so that we know how it looks. So since faces is a 2-dimensional array, we are going to detect the first face. We are going to store that first face in X, Y, W and H values. Once you have this, you can now crop that face. Not exactly crop, but you can draw a rectangle around that face using OpenCV. So in OpenCV, you can say cv2.rectangle. In my image, so IMG, what is IMG? Well, IMG is my original image, and in that IMG image, I'm saying draw a rectangle with a red color. See, this is RGB. R is 255. That's why this is gonna draw a red rectangle. And the rectangle dimension will be, it will start with X and Y, and then X plus W and Y plus H. And I will store that into my face image, and when I draw it, you get something like this. So now my face is very clearly detected. Now I'm going to draw the two eyes. So this is the code, nothing fancy about it. The OpenCV documentation has this code, so I have just done copy paste from there. So what we're doing is we are iterating through all the faces. In our case, even if you don't have for loop, it will work because we have just one face. And for each of the face, we are first drawing face image. So see, face image is nothing but this. So we are doing that, and then we are applying eye cascade. So eye cascade will give you eyes, and you might have multiple eyes. So you're going to run for loop on those eyes, and again do the same rectangle. But you see, I am doing rectangle in now green color. So this is RGB, this is RGB, this was red before. Now I am doing that in green. This code is extremely simple, believe me. Now you get these two eyes detected. In this code, ROI color was nothing but the rectangle region, that red rectangle that you're seeing for the face. So if I just plot ROI color, you will notice that I get a cropped face. And this is something we are interested in. I'm calling it ROI because it's region of interest. We are interested in the facial region of every image in our data set. So we will be cropping the face region from all the images, and we will store these cropped images into a different folder and use that for our model training. So now what I'm going to do is write a function where I can input this image. For example, I had this image, right? The original image. Let's say I have a function where I input this image, and function returns me the cropped face if the face and two eyes are detected clearly. And that function I can run on all my images. So let's write that function. It's the same code. I'm just creating a simple function out of it. So my image will be supplied using an image path as an input to this function, and it will read the image. It will then convert it to gray and then detect the faces first. Then you go through all the faces, and if the number of eyes that you get in your face is greater than or equal to 2, then it returns you the region of interest basically. So let's try this function on Maria's image. Whatever we did previously, we are now doing the same thing using the function. So see, this is the original image I have, and let's see what kind of image is returned by this function. So I'm calling this function on that image. I'm passing the path in that, and that function is returning me the cropped image. When I plot that image, it looks something like this. So this is pretty cool because this way I get a cropped image. Now, if the face is not clear and if the two eyes are not clearly visible, we want this function to return nothing because we want to ignore that image. Now, if you look at our test image folder, so let's see. So in our test images, I have this second image of Maria where her face is actually obstructed because the two eyes are not clearly visible. So I don't want to use this image for my classification purpose. So let's see how our function behaves for this particular image. So first I loaded this image and I plotted it here. So this is how it looks. Now I am going to call my function. See, I'm calling this function on this image, Sarapova2, which is this image. And when I run this function, I get nothing. So cropped image noise is now none, which means the face is obstructed and I don't want to use this image in my model training. All right, now in my dataset folder, I want to create a new folder called cropped, which I will do programmatically. In that, I want to store all the cropped images. So if you look at my original images, they are original and they have a lot of things, right? And I want to now generate a cropped folder. All right, so how do I do that? So the first thing I'm gonna do is initialize a couple of variables. So that / means the current directory. So my current directory for this notebook is this. See, here is my notebook. This is my current directory and my dataset is in dataset folder, which you can see here. And my crop dataset, so CR means crop dataset, I'm gonna store in the crop folder. Okay, and first let me store the path of all the individual subfolders in a Python list. So I'm using a Python's OS module, and when you do os.scan directory, what it will do is it will go through all the subdirectories within my dataset folder. So my dataset folder has how many directories? These 5 directories. Okay, those names of those directories are going to be stored in this image directory variable. So if you print that variable, it will look something like this. Now I have complete paths of individual folders for each of these players. So now what I'm going to do is, if crop folder doesn't exist, then I'm going to create it. So right now there is no crop folder inside my dataset. Okay, so let's see. So this is my dataset folder. This doesn't have any crop folder. You can see that, but this code will generate that folder if it doesn't exist. See, now I got crop folder. So what this code is doing, very simple code. What I am saying that is, if the folder exists, os.part.exist means, does this folder exist? No. Oh, sorry. Here what it is doing is, if the folder exists, then I'm removing it. So that if you're doing multiple run, then if you have some old image, you want to clean it. So first thing is, if the folder exists, remove it. Then this line will create that folder. So make directory will create that folder. So now I have this folder. Pretty cool. It's looking good, guys. So far life is pretty good. We have no issues. Now what we are going to do is, we are going to iterate through each of these image directories. So for image directory in image directories. Okay, so I'm going to iterate through all these images first, and I'm gonna build, let me just copy paste some variables here. So I will need these 2 variables. I will explain you the reason, but cropped image directory is nothing but it's similar to image directories, but it contains the cropped folder path for each of our 5 players. So when I go through this image directories, first thing I want to do is, what is my celebrity name? So I'm just again gonna copy paste. I'm doing copy paste just to save time. So when you do this, what happens is, see, what is my image directory? First of all, image directory is this. Okay, when I split this string by slash, it will give me these 2 tokens, dataset and Lionel Messi. Okay, and these 2 tokens will be stored in a list. And you know, in Python list, when you do -1, it will give you the last element from the list. So here what's happening is I'm splitting all these strings one by one and taking the last element, which will be the name of the celebrity. So if you want to just verify really quickly, and if you say celebrity name, you see you are now getting celebrity name in this variable called celebrity name. All right, what is my second thing now? So my second thing is I want to now iterate through each of these folders and iterate through all those images. So let's see what is my folder. So my folder here is, let's say, Lionel Messi. So now I'm gonna go through all these images one by one and use that get cropped if two eyes function to create a cropped image. Okay, os.scan directory is a nice function. You supply the image directory, it will tell you, it will give you the iterator which can help you go through each of the images or each of the files from that folder. Okay, so my entry, all right, so the entry.path, okay, entry.path will have the path of that image. On this path I want to call my function. So when I call my function, in ROI color I will get the cropped face if the face and eyes are clearly visible. If they are not, what will be the value of ROI color? We already saw that the function will return none. See, if you look at this function, it returns only if the eyes are clearly visible. Otherwise it returns nothing, which means it's none. So now what we have to do is, first we have to check if ROI color is not none. If this is not none, which means my face and two eyes are clearly visible, in that case you can store that image into a crop folder. So first you need to get individual folder for the celebrity. So what is path to CR data? So path to CR data is dataset / cropped. Okay, so let's see. So it will be this. In this crop folder, you want to create a subfolder for your player first. So who is a player? Well, celebrity name. Celebrity name is the player. Okay, so you are going to create a crop folder which will be path to CR plus celebrity name, which will be dataset / crop / Lionel Messi. Okay, if you print this name of the folder, it will print that. And if that folder doesn't exist, so here see, if this folder does not exist, then your first thing is you create the folder. Python's OS module is pretty handy. You just call os.make_dir and it will create that folder for you. All right, so now I'm going to just print this folder so that we know, it's generating this folder. If you want to run this code just for fun, you can run that. See, right now it is doing cropping. We are not saving the images yet, but I want to just show that you can see it's going through all those Lionel Messi images, creating cropped images and generating a folder. It's still working on it. Now see, it went to Maria Sharapova and it is saying generated a folder for Maria Sharapova and so on. Okay, so I'm gonna stop this cell. So if you click on this button, it will stop this execution because I wanted to just demo the code so far. If you look at your crop folder, see Lionel Messi and Maria Sharapova, you got two folders, but they were empty. So I'll just delete it. I will finish the rest of the coding and then we'll run the same code block again. Okay, so I have now crop folder. What I'm going to do is now I have this cropped image directories. That is nothing but a list of your cropped image directories for each of the sports person. In that, I am gonna append the crop folder. Okay, so this is just a helper variable. It will help us later on. So that's what it is. The code so far is extremely simple. Okay, I hope you're understanding it till this point. If you don't, take a pause, try to think about it. No rocket science, guys. This is extremely simple project. All right, now I am going to do one more thing, which is once you create a folder outside that if block, I want to generate the name of the file. So name of the file, I'll just call it like, you know, like Lionel Messi 1.png, Lionel Messi 2.png, and so on. I want to keep it that simple. So then I need a count for 1, 2, you know, so that's where I have count here. Celebrity name count.png. Now count I have not initialized here, so I realize I need to initialize that in here. Okay, and this will be the name of the file, and this will be the full path of that file. Now what we are going to do is this ROI color, we will save that as an image in this cropped file path. Very simple. Now how do you do that in OpenCV? cv2.imWrite. Very simple. What is the first argument? Your file path. Second argument, your region of interest. Whatever you got back from your get cropped image if 2 eyes. That's an awesome function we wrote, guys. We made a big achievement by writing that function. Although that function is a big achievement, there is one shortcoming. I will tell you so that you don't complain later on. If you have 2 images, it's gonna return only first image. Okay, so if you want to make this more robust, I'm kind of feeling lazy, but if you want to make it more robust, you can return 2 ROI colors as an array and then save those 2 images. Okay, but you know, sometimes I feel lazy and I don't care about little details, because guys, understand my schedule is very busy and I'm doing this YouTube thing on side, and I don't have time to go too much into details, you know, although I try my best, but you understand my situation. Okay, enough of side talk. Now once you execute this line, your cropped image is stored in crop folder. Amazing. But we need to do one more thing. We need to store the name of all those image file paths into a dictionary. That dictionary will be useful later on. So this is that dictionary, celebrity file names dictionary. So what is this? So the key in this dictionary will be the name of the celebrity, and the value will be the list of file paths. So it will look something like this, guys. See, you will say Lionel Messi, and it will have the file path, you know, like datasets, crop, Messi, whatever, Messi 1.png, Messi 2.png. You know, you want this kind of dictionary so that it helps you later on. We'll see how it helps, but you know, like, you get an idea. This is very easy. You are creating a dictionary where you have the path of all your cropped images stored here in this beautiful looking dictionary. See, this is the dictionary I'm trying to create. That is celebrity file names to dict. Now here I can append, but I need to initialize the key of this dictionary somewhere here. So how do I do that? Well, you can just do this. Okay, so what is this? So when your dictionary is empty, the first key is Lionel Messi, and you are creating a blank array. So blank array will be this value. And once you have blank array, you can insert all these image paths one by one, friends. That's what I'm doing here. All right, now looks like my code is ready for big execution. So I just want to see that I'm not doing any bluff. I have only crop folder, it is blank, and now I'm gonna do control execute. So now it's executing the code. It is going through all the images, generating the cropped images. I paused this video while this was going on because we were doing some heavy lifting. Based on your computer speed, it might take you a few minutes. But after this execution is complete for this cell, let me show you how my crop folder looks like. So crop folder, you see now it has 5 beautiful subfolders. In each of these subfolders, I see the cropped images. See, I see cropped images, guys and girls, cropped images. My life is pretty cool. See? Okay. Now one issue you notice is we have cropped images, but then we have an image of Venus Williams. She's a sister of Serena Williams. We have this image which looks pretty blurry. Then we have this image. I think this person is Serena's husband, I think, if I'm not wrong. See? So what is this person doing in Serena's folder? So what happened was this image. So this image, see, it has this face. So it just returned that face into a crop folder. So using Python, you can crop these images, but you can do the data cleaning to only certain extent. Most of the companies, they will try to do data cleaning in as automated way as possible, but you have to rely on humans to do some manual remediation. So many companies, what they'll do is they will hire this workforce in countries where the labor is cheap. Some companies also use crowdsourcing platform. For example, in our case, we can easily use a crowdsourcing platform, and we can throw these images as a crowdsourcing job, and we can ask people that, does this image look like Serena Williams? And people will easily detect this, and they'll say, no, this doesn't look like Serena Williams. In that case, you can delete the image. Okay. So companies have this workflows where they use crowdsourcing platform or many different tools and assign these micro tasks to people, especially in the countries where the labor is cheap, to do manual remediation or manual cleaning of these images. Now our data set is small, so we are just going to eyeball and clean these images. Okay, so what I'm going to do is go through each of these folders. See, just quickly. It's okay if we are not for okay. So this looks like Serena Williams, Venus Williams, her sister. This image is blur, so I'm deleting it. So I'm just manually deleting it. So now I'm done with my automated way of data cleaning. Now I'm doing manual data cleaning. See, this was a background image which it caught. See, this is an image of someone else. Okay, so Serena Williams folder is clean. Similarly, see, I look at Lionel Messi and I see this boy's image. Maybe this is Lionel Messi's son. This another boy, so I'm gonna delete that. Virat Kohli, my favorite player, Indian cricketer, and I see this blur image. I see this another Virat Kohli. See, I want to delete that guy. And then see Anushka Sharma, like her wife, his wife. I see 3 images. See, 1, 2, 3. Oh, I see Deepika as well. Okay, delete all those images. And once you delete all these images, you have a clean data set. that you can use it further. Okay, so that's all I have for this tutorial. In the next tutorial, we are going to look at wavelet transform and how we can use that to generate the features. And we'll use wavelet transform as well as these raw images for our model training later on. If you're liking this series so far, please leave a comment below, because your comments kind of helps me in designing the future content in a better way. So if you like projects like this, if you want me to build these kind of projects, please give it a thumbs up or comment below, so that I know that there is a demand for doing these kind of projects, and I can maybe focus more on these projects in the future.